Hello everyone, welcome to the second part of the data analysis video. In this video, we are continuing to explore our snow and ice removal data set. In previous video, we finished doing our gathering, wrangling, and assessing our data sets and checking for the missing values. How can we search them, and how can we look at our shape of the data, and how can we check whether our values and the variables are consistent, so on and so forth. It's been a long video. Now we are going to continue with the exploratory data analysis. Now I'm going to merge our data sets. So we had three data sets, as I mentioned before, and population, road miles, and snow and ice cleaning data. Now I'm going to drop count to variable here because it's actually repetitive column. We don't have to, if we just join this one as well, it will say county and county X or county 1, right? And we don't need it. So since we have already, we already have another data set as well. So we just merge our data set using pd.merge function. This is another method from the pandas. And you can just, this is our left data set. This is in the right data set. And this is actually, let me check it. It has to be doing inner join. If you guys, for example, let's just series, yeah, left, right, we can just pick that. But if you don't pick any left or right join, it will just do inner join, as you can see here, default value. So we are using DR code and municipalities, which are the, we mentioned those are our unique identifiers. We are using those values and to merge our data set. And this is our new master data set, consists of from those three, we acquired from those three tables. Right, okay, in here, I created this grab call names function. It will separate our column types into three groups, and categorical columns represent cat columns. It will represent the categorical columns. Second one is numerical columns. Third one, categorical but cardinal columns. Why I included this one? Okay, for example, if you can't do one by one in many cases, because sometimes you are going to deal with many variables. Maybe your tabular data will have 300, 500 rows in your data set. You can just check one by one which one is categorical, which one is numerical, right? So you need to somehow use some functions or somehow automate this process to make it faster, because we are programming also doing data analysis, and functional programming is really important in this process because we need to fasten our projects to make it more easier for us, right? So what it does, let me just mention here, what is the categorical but cardinal columns? That means there are some categorical values, it's repeated so many times, and it's become meaningless to just see them as a categorical column sometimes, because, you know, for example, let's say we have 351 row, right? And the same categorical columns is just repeat 351 times. It's not going to help us to just define that one as a categorical column. For example, is a municipality here. We have 351 rows. And if we just, yeah, this is a categorical variable, but it's not going to help us to just, you know, do some descriptive statistic, right? If we could do the value count, which is the most important method in the categorical columns, it will just count each one is one. It's not going to bring us any valuable information to interpret our data, right? So here, let me show you this function here. Snow and ice, right? This is my folder here. Let me just bring it to those helper functions. I'm going to open it in my Sublime text. It's going to open. So basically, this grab call name function takes the data set and the categorical threshold, as I mentioned here. If values in that column is repeats less than 10 times or 10 times, we can change these values. These are the default values I added. That means, let me open it and show it. here. Sorry. Okay, so yeah, let me just find that function first of all. Okay, grab call names. As I said, it takes data frame and categorical variable threshold and cardinal threshold. As I mentioned, cardinal. If value in the categorical variable repeats more than 20 times, it will assign it's the cardinal variables. But I should be increase this one, and depends on the data set. But in this data set, these values are appropriate. So categorical threshold value is 10. That means if there's a value in that variable and a different observation is repeated 10 or less than 10 times, it will assign as a categorical variable, even if their variable types is integer, right? For example, we can just grade people 1 to 10, right? Or 1 to 4. They are numerical. We can write them as a numerical 1, 2, 3, 4, but as we know, this is a categorical variable. Regardless, we just write them with the numbers, right? What it does is just it gets the, for example, cat calls, call for call in data frame calls. As you guys know, this just gets the data frame columns and take the data types are objects, right? Then using those categorical threshold, and we are getting the even if they are numerical, right? If they're less than the number of unique values less than the categorical threshold, in this example is 10, and also data types are not object, right? We are looking for the numerical values, which seems as a quantitative, but we are going to check them whether they're qualitative or not. Then it's the same method. If you guys don't understand this function, please let me know. And I don't want to just explain everything one by one. And the main idea, you guys, I hope understand it, right? It's just the checking those thresholds and just assigning the necessary data types to those values and return us the 3 different Python list. Okay, let's just print the categorical columns. As you can see, county, massport, and fiscal year, state reimbursement received, federal reimbursement received. As we know, this county is, yes, this is the categorical variable, right? We know that these are the counties, but massport, these are the areas, right? And how long massport areas is just the road mile values. This one's come from the road mile table. This fiscal year is just one value, right? But it's even if it's 2022, but it's just repeats one time. There's one value in that value. There's one value. So it's C as a categorical value. This is how our function works. State reimbursement received, federal reimbursement received. That means this values in our data sets is repeated less than 10 times, right? These are actual numerical values, but in the observation of our 351 rows, that means this federal reimbursement, state reimbursement, and massport is repeat less than 10 times. That's why our function catch them. But as we know, these are not categorical. We are going to change it, right? Okay, so what I'm going to do, and just create a list of move columns. I'm going to move this one as a numerical columns for my analysis, right? This is a small data set. Maybe you don't understand the importance of that function, but it's a really useful function to understand in the future, because you will not able to understand the, let's say, 600 variables or more than 100 variables to look each of them one by one to get the quick understanding, right? Okay, so what I'm going to do here, and just using those move columns, I am just extending my numerical columns using the extend method from the for the Python list, and then running this, then also removing the your code from the numerical columns, because it's just Unix index and identifier, we don't need it, and also removing fiscal year from the categorical columns. I'm using here lex comprehension method from the Python. Basically, it's just a for loop, and you are just creating a new list from that for loop. What I'm going to do, call for call and move calls, right? If call yes, call in categorical columns. If that column not in move columns, these ones, right? And also call not in the fiscal year, that means those are categorical values, which is just a county actually. But why I did this way, because this is programmatically, you will not able to hard code everything. You have to do it with programmatically, which is going to help you in the future. Okay, let's run this and print categorical columns. Sorry, actually, let me run this because I've run it twice. It's giving me an error because there is no DR code because we already run this code. That's why I got the error, right? Now, categorical columns is a county, and this is my numerical columns, which is correct. And this our categorical but cardinal, right? This municipality is data types is object, right? The municipality names like Boston and Cambridge, but as you can see, these are repeated many times. So we are not including our analysis, right? So which is a good way, right? Okay, so so what was our cardinal threshold? It was 20, and this one is repeats 250 times. As we know, this is because like an index. Okay, I created this cat summary function. Let me just run it, and then let me explain you how does it work. So it shows us the county, right? And how many, for example, it takes the master DF, right? At the data frame and column name and plot through, and it shows this visualization. And we are doing the for loop in the categorical columns. We could do one because we have only one categorical columns. As I said, this must be programmatically. We might have more than one in the future, right? Okay, what it shows here, each county getting those column name. Let me just open this function and explain you here. Yeah, EDA pay, not target. I created some different functions. I correlated, no. Yes, what does cut summary function here? Let me just make it a little bit closer here, right? Oh, I can't. Anyway, so what it does here, let me just copy this part and then bring it here, right? So what it does and gets those column name, right? And from the gets a column name. What is column name? This time is county, right? And it gets the count name and do the value counts for, and this is value counts, right? And it's just the value counts. Worcester is 60 municipality. That means Worcester has 60 municipality, and the ratio of the whole data set, and it means 70%, 17% of the data set. So what it does and how do you calculate the ratio? 100 multiplied with the column data frame value counts divided by the length data frame. This is how this function, and also we were showing the count plot, which is almost the best method to observe our categorical variables. And if you're going to use this visual, I would recommend you to, instead of using, this one is not conveying the message. It's really important to, give the correct information to your managers or supervisors, because this one, as you can see, I can see sometimes Worcester is the highest one, but which one is third one? So ranging them and ranking them actually will be really helpful to see this information. But as we can see, there are this county just have one municipality, but Worcester, Middlesex, and Essex, and they almost have the 50% of the municipalities in Massachusetts, right? So this is how does it work. As I mentioned, it's not really complicated. For now, I have numerical num summary function. It's the same intuition, same purpose. We are getting the data set and the column name. We are looping through the numerical columns and plotting one with the histogram. Let me show you that one as well. And as you can see, this is the num summary function, right? Let me just copy this part and just paste it here. And Okay, what it does, it gets the describe part. As we know, the describe is just to show the numerical values and their count, meaning, and the other descriptive statistics. And what we are doing that after that one, check whether there's a null value, right? And also, and just plot histogram or box plot, depends on our need. I'm going to do in the little bit below, I'm going to do outline analysis. That's why I just picked the histogram. But in the first glance, I think histogram is much more sense to me. Of course, you could go with the histogram box plot as well. So here, as we can see, we can start to analyze our data. For example, this one is, which one is the population? As we can see, we talked about this before, you know, it has a high variance. Some municipalities really high population, some of them is really low. As you can see, there are some municipalities is just consist of the 64 people, but this one is actually Boston. This is the their population right now, right? So as you can see, this is the right skewed data. It's the real world data is usually right skewed, right? Many as we can see here, many of our municipalities almost less than 100,000. So this is a really things, and this is the our median values. As you can see, is half of them is almost under 10,000, right? Okay, this one is, as we mentioned, mice highway. How can we, I'm interpreting this histogram, it might be helpful. What we are seeing here and how many of them, this one is how many of them and how much. For example, let's say this one is just one. That means just one of them is just this amount, right? And it's not repeat many times this amount. For example, over 40 miles, maybe there is just one municipality. But as you can see, this one is 50 of them is almost zero. It's actually zero, right? As we can see here, mean 20%, right? Yes, minimum is zero, and half of them is less than 8 miles has. That means they are real rare in our municipalities. And city town accepted, as I mentioned in the previous video, we are going to use this one in our analysis because municipalities are responsible to remove snow and ice from these roads, right? And as you can see, this is also kind of really, you know, the light right skewed. But as you can see, this is much more sense to when you compare to others. And but minimum is 2 miles and maximum, as I mentioned, 790 miles. And this is the median value. And as we can see, there is some high variance because of this min-max values, right? Yeah, this is the DCR. As you can see, even the 75% is zero. That means this is rare. If we do some outliers analysis, probably our functions or analysis will catch this, but it's not about it's actually outlier. It's just almost rare in many municipalities doesn't have this variable, right? As you can see here. And same as well in the state parks, as you can see, you know, the zeros are almost over 300. So we already have just 350 different municipalities, right? These ones in 3, and a few of them is 10 miles, right? As I mentioned, this one is amount of the state parks. This x-axis, this one is the x-axis, right? And this one is their count values, right? This is what histogram shows us. And this is the state institutional, same as well, same result, 75% is zero, same as well for combined federal, right? And 75% is zero. That means 75% of the municipalities doesn't have this. It's rare, right? As we can see, there is only one state is just has some 25 mile and over 25 mile, maybe one. These ones probably one. Yeah, one of them is just so more than 20. Yeah. So same as well, almost the same result. Right skewed data, total miles, as you can see, city town accepted, it shows a similar yeah, similar behavior. Here, standard deviation is really high. That means we have some municipalities have really high roads and miles, and some of them are really small. So as you can see, this is some of them is zero. I don't understand how it does work, but this is how data is just there. This is our original budget. Many municipalities seems doesn't have really high budget here. As you can see, this one is 1087 means is I think 60 plus 60. This means, for example, this one is over the 20 million, I think. Yes, as you can see, is 200 actually. 28. How many is 3? 2 million, over 2 million budget for the 2 million, and some of them has supplemental funding. As I mentioned, we have some minus funds. These are probably budget adjustment. As we saw here, many of them doesn't have supplemental budget, right? We know this value comes from the that municipality we mentioned before, Brockton, I think. And as you can see, this municipality, 28 million, is Boston, I think, has total expenditure in snow and ice removal, as you can see. These are the deficits. Some of them is mean. So as you can see, these are the minus value. We should consider this one as they are shown as a minus. We should consider this one as well, right? And as you can see, many of them is close to zero. Some of them is really high, over a million, right? Anyway, so this is how we are interpreting these values. And just to show you, for example, this one is really rare. One of them is just has it, right? As you can see, even max is 0. Oh, none of them have it, actually, I think. Nobody gets state reimbursement. All of them are 0, as we can see here. Actually, just one place probably have federal reimbursement, as you can see, max here. That's why we're seeing here. And one place is get the federal reimbursement, and we are checking this one here. And Abington, Palmouth, and there's one place is get the federal reimbursement. I think it's not common as well. There are no state reimbursement, right? From any, there is no municipality get the state reimbursement. As we saw, population, as we mentioned, population varies significantly across the municipalities. We'll check the mean and maximum values. As we mentioned, in structure metrics and mass size to time expected, and some of them is real rare in the municipalities. We already mentioned this one as well. We observed those one, and we set the budget and expenditure. Again, significant variable because of some big municipalities and counties, and we mentioned there's almost no reimbursement except one place get federal reimbursement, right? And that one is Abington, I think. Okay, let's just jump into the outlier analysis. Why is important outlier analysis in machine learning? It depends on what are you going to do with the outliers is a business problem, and many times keeping them will be more appropriate way. But I am going to show you something. If there is an outlier in your data set, it might lead you to wrong conclusion. For example, you might see the really high mean. People many times give example in the cafe. They are sitting, side by side, and we are just looking their mean income. And now Mark Zuckerberg or Bill Gates come into cafe, and now their mean is increased because when we are calculating the mean, what we are doing, their income, we are summing their income and dividing how many people in that cafe, right? But if somebody is coming really high income and for the division part, we are adding just 1, and it will increase exponentially, right? So that means it will affect your mean value. So in those cases, looking median is give you a much more sense idea to interpret your data set. Here, I created check outlier function. What this function does. So this function is basically takes the data set, and we are again doing the call name and num columns. We are going to look through each numerical columns and sending those with our data set to this check outlier. What this check outlier function does, let me just copy its code again, right? Not this one. Yes, this one is check outlier. This part is the important part. Other part is just documentation. What it does here is just first calculates the up and low limit. We are using statistical methods called quantile, interquartile methods. What it does here, and this is another function actually. Let me just grab that one as well. This one. So what happens here, right? So first, in the outlier thresholds, we are sending this data frame, just calculating the first quantile. What is first quantile? This one is we are giving here is the quantile is the 25% of the data. Let me show you here. That's a value we calculated from the describe, right? This one is, for example, 0 here, right? And 75, again, this value. But in this function, these are the arguments. You can change it. How can you change it? You can actually, they have default values at 25 and 75%, but you can just change it, depends on the value. Sometimes we need to suppress our outliers, using these values, but 25% and 75% of the data is really change the shape of or variability of our data. We sometimes just 1% and 99% just give the some good to our machine learning model if you're using machine learning. What it does here and just calculates the first quantile, 25% of the value. Second one is 75% of the value. And what it does is interquartile range. We are just subtracting 75% value from the 25% value. In this example, as I said, we are using those ones and just calculating using interquartile method. Quartile, we're plusing that quartile 25% value plus 1.5 multiplied with this interquartile range. We get it subtracting this two value. Same method, we are just now getting those value. For example, this one is 25% minus this one, and it gives us the up and low limit, and we are using those up and low limit and just getting whether is there any value in our data frame, giving that column. Is there any value in that column, our data frame, let's say in the massport from the up limit? Or this one is or in Python, by the way, in pandas. And we are looking, is there any variable in observation in our data set is lower than our low limit, right? Okay, I hope you guys understand it. If you didn't understand it, and please let me know. If there is a value in that, we are returning true, right? If it's true, if result is true, just I created this empty list and just add those lists to our add that column to our outliers list, right? Let me run it and let me show you, right? Okay, which ones are outliers? Mass population, mass highway, city town accepted, DCR, state park, state combined, federal. Okay, I hope you guys maybe see that these values, combined federal, I have mentioned those ones are rare, and because they are rare, their value is same as in our function. They're outliers. There actually is just many of the state doesn't have those. That's why our function catch those, because there is a really high value. It seems, the mean value, or as you know, many of them 25%, even 75% are 0. If we use that method, there is maybe some municipality has those values, right? Or a few municipalities have those values. And as you can see, they could catch those values using this method. Okay, so I mentioned the same thing. So I'm going to remove those ones from this analysis, these ones, okay? So, and then Okay, so let's just to check. I'm going to show you something here, how these outliers are going to affect our method, okay? Just a real, let me just give you a small break and I will continue from here. Here is just in two different variables, I'm going to check the outliers and how they're affecting our mean value and our descriptive statistic in our data set. As you can see, describe outliers function is this same, similar to this function. It's going to get outliers, but also it's going to get us their indexes, which rows are outliers in our data set, right? I'm using the same method, 25 and 75 quantiles, and also not printing the table. This function is the same things. And we get to their indexes. As you can see, let me show you these indexes real quick here. These are our indexes. And these indexes are catch as an outliers by our function, right? So this one is I'm only going to get to these two columns, and because I'm going to get the deficit in this one, what I'm going to do is just getting those indexes and also getting these columns, right? And let me just run it and just show you. As we can see, those indexes, what we get catch with our outlier function and these variables, deficit and municipality name, county name, and deficit reported in our own balance sheet. Let's just do the which counties. Let's just do the value count, Middlesex, most of them from the Parliaments, and Bristol. As you can see, there's one in Franklin and the other states as well. Mostly from Middlesex and Parliament, as I mentioned that one. And just let's do, I'm going to do the same observation with the total expenditure. As you can see, the same things, we are getting the indexes. This time we are using total expenditure columns and the same column names, and with the indexes, we are getting those municipalities, right? And as you can see, Essex, Middlesex, and Norfolk with total expenditure. There are many outliers, how many outliers value municipality they have, right? And as you can see, I created this this code here. What is this? Gets the deficit reported on the balance sheet with outliers. I'm calculating the mean with outliers and median with outliers, right? And I'm then removing outliers from those data sets and calculating the same mean and median value without those outliers. Same thing I am doing with the total expenditure, getting calculating the mean and median value with the outliers, median value, and also calculating the same values without outliers. Let me run this, and it's really intuitive. You guys could just understand this code. If you don't, just let me know. As you can see, with outliers, mean value is 58,000. Deficit reported on the balance sheet variable. As you can see, without outliers, mean value is 0. I'm trying to explain here. With outliers, outliers are going to affect your descriptive statistic. If you just provide this mean value to your manager, that means they're going to, wow, that means many municipalities has deficit on their balance sheet. It's actually not true. It's come from the really big municipalities like Boston, right? Because they have really big deficit on their balance sheet. Same as well total expenditure, maybe not here 0, but as you can see, almost twice as the other one, and the median value as well. There's no big change in the median value. I don't have to expect it, but there's a little one, but we can take into account the median value. As you can see, it didn't even change without outliers, right? And a small change here as well. Okay, so we are going to plot those outliers here, and this is the pair plot method. What's going to do is we are going to give these variables outliers for plot, right? And I just exclude a few of them because they're not useful for us. And it will get that data set, those variables, and just create a pair plot. We will see the each of them. Let me show you here. As you can see, those ones, population, for example, with population, city, town, accepted, original budget. As you can see, what can you see here? These values, as you can see, just 1, really outside of our observation. These are our outliers. You can see that as you can see, there's some correlation between those values, but it's a different topic. But it shows you that those values are outliers, and you can observe those ones. This is another visualization method, and it's really intuitive. I'm sure you guys could use it in the future as well. So now instead, I created this correlation function. What it does is just the data frame and just calculate their correlation. But I put in a threshold here. If their correlation, absolute value of the correlation, as you know, correlation is range of values -1 to +1 actually. And I just adding here this threshold, but I use the 0.8 threshold to see the correlation between those values. What it does is just to get the correlation value. If you run this code, that will just give you the number of the correlation. And then I'm just getting the triangle matrix here. And if they're higher than the absolute threshold value, give me those values, right? Then this is the just visualization method here. And if you guys know I can explain those visualizations a little bit later because we will have another data visualization part here. Okay, as you can see, these are the sum values. For example, as you can see this map, we just picked 0.8 correlation threshold, and we use these values, right? These ones, these variables here. Population, for example, it has 0.85 positive correlation, this one. As you can see, if they're red and minus, this means a negative correlation. Correlation is, as I mentioned, from -1 to +1. And if it's close to 0, that means there's no correlation. And if it's either side, minus or +1, is correlation getting higher. If it's just higher than the 0.5, that means correlation is really high, getting higher. And if you go to -1 side, that means there's a negative correlation. If you go to +1, that means there's a positive correlation. That means, for example, let me just look at the highest one. Highest one is population with this one is the highest one, right? And 0.94, as you can see, which one is it? Total budget, which is really intuitive. And if the population is high, the total budget will be high, right? There is a positive correlation. It has a negative correlation with this variable. Which variable is it? That means deficit reported on the balance sheet. How can we interpret this? That means if our population, when our population gets higher, that means our deficit on the balance sheet get higher, but it's as you know, the deficit on the balance sheet is a negative value. That means it's just getting lower, but it's actually getting bigger. But just to understand, don't confuse yourself. Population and the actual deficit on the balance sheet is positive. There is an actually misinterpretation here, and I should just use their absolute value as well. Actually, there is a positive correlation. Sorry about that. I'm just now I realized when I explained it. As you can see, you can just look at those variables as well, right? This is how it works. Okay, so you can just see that those hardcore. If you are going to do in this, do some regression analysis. As you can see, highly correlated values are carrying the same information. So it's not going to help you to use the same value. For example, total miles and city town accepted, they're almost carry the same information. Using both of them in your analysis is not going to help your analysis. Actually, it might, mislead your interpretation, right? Okay, I mentioned just to get the high correlated value, except to this one. And again, I'm just showing this pair plot here. And then we will just pass the visualization, and I will show you how can you create visualization using Matplotlib and Seaborn. And let's see this one. And like we did in the before for the highly outliers variables, now we are doing is the correlation. As you can see, for example, you can just observe this one. There is a really high positive correlation, city town accepted. For example, here, total miles, which is makes sense, right? Which one is the goes to, for example, this one. This one has its really total expenditure and the total budget has a really high positive correlation. You can observe those ones with the visuals as well. Okay, there are some comments here. You guys can read it. I'm stopping the video, but this is the second video. After this video, I'm going to jump on the visualization. There are some nice questions and we will create nice visualization. Then, as I said, we will go to data modeling. Then we will create dashboard using Power BI. It's going to be cool. And data modeling and the importing our data set in the PostgreSQL will be cool as well. Okay, thank you so much for watching my video, guys. I hope you guys enjoyed it. It's really getting longer. I really want to explain everything, but please feel free to ask any question. But as you know, sometimes you need to make your own research for how some functions work. But I'm happy to answer. Just leave a comment in my videos. I would love to explain any concept or how programs or functions or some syntax works, okay? Hopefully see you in the next video. I hope you guys enjoy it. And thank you so much for watching my videos.